Palo Alto studio connecting Silicon Valley and Wall Street.
I'm John Furrier, co-CTO here with Dave Vellante, my co-host.
Hello, I'm John Furrier, host of theCUBE here in theCUBE's NYSE studio. Of course, we have our Palo Alto studio connecting Silicon Valley and Wall Street. This is our AI Factory series where we interview the leaders who are building out the AI infrastructure that's enabling all the innovation and societal change, and of course, economic advantages across the globe. It's a global opportunity. And we're here talking about purpose-built silicon. Sunghyun Park, co-founder and CEO of Rebellions here, hot companies building large-scale systems and deploying them and providing the products that we need to be successful. Thanks for coming on theCUBE on our AI Factory series.
Thank you for inviting me here. It's a historical place here. Yeah. So
the AI infrastructure is continuing to grow. The demand, we're seeing build out, obviously we're seeing some of the supply chain challenges, but that's not going to stop the momentum. And it's changed. So my first question is, what's been the big changeover that's made you successful in this market? Has it been the paradigm shift to large scale systems? Has it just been AI in general? What's been the big driver for your success?
So one word, it's inference. Right now, market is from training to inference. And in AI perspective, right now, moving forward from occasional AI to always on AI, real-time AI, and also running at scale, the inference, billions of per scale per day. That's the key difference. Training-wise, raw tops, interconnect is much more important. However, in inference, efficiency, especially cost and energy efficiency, matters most.
Yeah, a lot of inference going around. I want to get into some of the systems that you have and some of your strategy you guys have been executing on. But first, you guys have a purpose-built silicon that's the engine of the AI factory. Okay, explain the purpose-built chip definition and the role and the importance of the role of purpose-built silicon.
It basically compared to general purpose GPU, for example, GPU, general purpose GPUs. Our custom silicon and purpose built is 100% optimized a single workload. For example, our Rebellion case it's kind of inference. In terms of the caving cache, it's not a software solution at all. Right now, we are highly focused on memory-centric architecture. It's 100% optimized for inference workload that include the caving cache here. Also, in terms of enable scale up and scale out, we need a specific hardware primitive. That kind of primitive also hardwired inside a chip. We call that purpose built, not general purpose. So compared to the general purpose, we a little bit compromise of or sacrifice the flexibility, functional diversity. However, in terms of intelligence per watt, per dollars, we can offer a way higher efficiency.
I love the AI factories because it's like everyone's cheering for you back here. They
What's
love
going on right there? Yeah.
Big trades are going down.
Yeah.
They heard our AI factory narrative, but the AI factory is fascinating because you have almost an inverse of the technical architecture mindset of the old generation. You build a server, everything's on the board. Now you have density. You have a lot of chips working in concert. It's a collection of systems operating as one system.
Yes.
So you can almost say an AI factory is a super server. It's a supercomputer. What does that mean for architecturally for inference? Because we saw the training, throw everything at it, train everything. Now you have inference, which is much more broader opportunity, bigger opportunity.
Exactly.
It's different use cases. How does the architecture need to be in place for inference? Is there a rule of thumb? Is there a general principle? Take us through the thinking around how to architect for an inference world.
Exactly. From the market perspective, we have totally different physics and tokenomics. In training, the performance is much more important than any other metric. However, in inference, as long as you can meet some minimum requirements such as SLO, minimum first token generation time, the token per second, nobody cares about performance. They care the performance per watts per dollars because inference right now is being commoditized. So efficiency matters most compared to training wise. Training basically we have biggest part, interconnect all the chips using the InfiniBand, the NVLink. However, in inference, we're a little bit different, a little bit sacrifice, we compromise a little bit. However, efficiency is the most important metric in the inference era.
You mentioned on the intro, you talked about energy.
Yes.
Energy is on everyone's mind. The entire scale is bounded by energy. How does the energy equation change when you start to look at the diversity of deployments? You're going to have the big mega centers. You're going to have kind of like maybe smaller footprints still doing, maybe 10 kilowatts. Then you're going to have smaller footprints. You're going to need to do inference everywhere.
Exactly. That's the key point. Basically, we call edge data center and the backbone data, something like the gigawatts or something. Right now, most of the AI inference running at the data center, but in the future, near future, some of the edge data center, some of the on device, depending on the model size, the parameter size, also some system requirement. If you're running very latency critical application, you don't need to go to the backbone data center, just edge data center on device good enough. However, depending on the system requirement, the model size, it diversify all the data center depending on that's why inference is totally different physics and tokenomics.
Yeah, I mean, there's so many things that jump out. First, we talked about data. Got to get the data close to the processing units. That's key. Memory, energy, always the discussion. Now the new conversation, this has been kind of in the inner circles of the leaders, but now it's going mainstream, is the role of networking.
Exactly.
What's your vision on how the importance of networking? Because when you add energy, moving things around requires energy. Data is being moved around. Networking seems to be something that's not talked about a lot. What's your vision and role, your view of the role of networking?
Yes, network is super important, but sometimes ignored because too much tacky right now. Somebody talk about the Ethernet, so scale up, even between the data center, not just the rack to rack, not just chip to chip. We definitely need such kind of networking. That's why everybody talks about photonics and optical. It's not a future. We almost there in terms of commercialization. So we need to get some low latency and the higher throughput, even in the lower energy to communicate the data, even at energy.
I ask dumb questions at these events. I look at the big NVIDIA rack and I say, wow, that's a lot of product in there. Why so many switches? If you look at the number of GPUs, the chips, the switches take up a large portion of the racks. You guys are in the rack scale business with Rebel. You have a lot of developers. Just what's your vision on how the racks will change? Because again, we're going to need to squeeze as much energy and footprint out of the racks and their deployment.
Yeah, basically, as mentioned, we are preparing the rack scale solution, not just server, not just a PCI card. Why? We need the system level optimization, cost layer optimization. As you mentioned, a lot of switch and storage, a lot of optical interconnect right there. So it's not just the memory pool. We need some new memory architecture combined with the networking. So in order to deliver lowest cost and lowest energy consumption, given the normalized throughput, the token throughput, we definitely need cross-layer optimization at the rack scale. NVL72 from NVIDIA is one example right there. We also need Ethernet-based standard. Also, each layer must be customized. Cross-layer customization. That's why we need to prepare rack scale solution, not just a sub.
And you're working on that now.
Exactly, yes. Right now, our rack scale solution is working at SK Telecom and Korea Telecom, top 2 data center company in Korea. Improve our lower TCO, lower CapEx and OpEx simultaneously.
Talk about the role Korea is playing in the global scale. You have investors, you can name them. I think they're big memory players. Talk about the role of Korea in the global AI infrastructure.
Yes, especially in New York Stock Exchange here. Right now, Transformer itself, right now, the heart of the LLM right now, Transformer is very memory hungry architectures. It's all about the memory. For example, as mentioned, Rebellion is strategically backed by SK Hynix and Samsung Foundry. That's the good thing, especially it's really weird supply chain right now. But the point is here, without the memory, without economics of the wafers from the foundry, not able to deliver the custom silicon at all. Why we need a custom silicon? It's a cheaper, lower cost of the token, but without such kind of collaboration with the memory and the foundry.
Well, it's cheaper, but also energy efficient.
Exactly.
You get a lot of integration with that chip, and more will be custom than less in the future.
Yes, so memory right now is not a commodity at all. Memory also need to be customized each customer. That's the future of memory. That's why Rebellion is focused on memory-centric architecture, collaborating memory vendor, optimize our logic, cross-layer design, the memory and logic.
We were having a conversation on X and I think maybe LinkedIn about this. When you have these constraints, engineers like to work around constraints. Have there been some new engineering directions? Because we don't want to be constrained on waiting for memory. Are there new architectures emerging that you're seeing that are promising to help facilitate faster deployment during a constrained environment like memory?
That's cool. Maybe that's one possibility of the new innovation right now. So then we need a new material from the scale up solution. Also some innovation, the logic. That's, I think, a good starting point of the innovation. But it's not very good story to the memory vendor. But again, let's see what's going on.
Well, people who have good experience with servers and rack scale will certainly can maybe make changes. Yes. I think it's opportunity that we'll keep an eye on that. I wanted to get that out there because it's got we see entrepreneurs all the time. That's what they do. They'll innovate. What's the constraint? I'll get around it. All right, let's talk about your business. How's that going? Share your momentum because I think it's important to point to. You're starting to see the global distributed computing network. It's global in scale. Sovereignty is a big discussion, both on cloud infrastructure and AI. Talk about some of the momentum. How's the business going?
Sure. Basically, we're a Korea company. We're headquartered in Korea. We spent 5 years in Korea collaborating SK Hynix and Samsung Foundry to deliver the memory-centric architecture. Right now, we have commercialized our product eventually. RebelServer and the pod in SK Telecom and Korea Telecom. Top 2 data center company Korea. It's not a thesis. It's not just a paper research. It's commercialized. They've deployed more than 100 of the server racks.
You have product commercialized now, RebelServer.
Yes, exactly. Right now we are serving actual end users. Commercialized. It's SK Telecom here. Up to 50 million API call per day using our chip. It's more than
It's battle tested.
Yes. Based on the reference, we like to expand our business globally. Based on telco business, enterprise, and sovereign AI. They need sovereign AI, a lot of definition of sovereign AI however, from hardware perspective, it's heterogeneous compute platform where NVIDIA and non-NVIDIA coexist, depending on the requirement. Also, sovereign AI doesn't want to lock in by NVIDIA. So NVIDIA, non-NVIDIA, TSMC, and non-TSMC, all compute platform coexist in order to avoid any supply chain issue and the geopolitical landscape.
Yeah, interoperability is a concern. Open systems is another big one. What's your thoughts on and perspective on open?
Open, especially in software side, a little bit sacrifice the performance optimization. We are fully relying on open source software ecosystem like PyTorch, Torch.compile, and VLLM, and the Hugging Face, instead of the building our proprietary software stack. That's the future of our direction and our second generation AI chip. That's exactly same as Linux moment in CPU. Why Intel beats IBM 20 years ago? Because of the Linux open source ecosystem. Exactly same thing happened in inference era. VLLM, PyTorch, and Hugging Face. We are focused on the open source ecosystem.
Well, congratulations on the great success on the server. Rack scale you mentioned is coming soon. How's that demand curve look for you? Because right now you're looking up and to the right, and you haven't even shipped your rack scale system yet. What's your thoughts on how the business will unfold? Assuming some constraints, but that'll get fixed quickly, sooner than later, we hope. But it's happening. What's your view of the future?
I hope so. Demand-wise, as a CEO of a AI chip company, demand is huge. Okay, Sunghyun, bring your chip. I don't need to evaluate chip. Just bring a chip as long as you can supply your chip for a long time. But the current issue right now, as you mentioned, is supply chain. How to manage all the supply chain, not just DRAM, not just HBM, even the PMIC chip everything is struggling right now. So, but assuming that the supply chain is going down maybe in next 2 years or something, the real game is right now how to efficiently map all kinds of inference workload given the single platform.
My final question for you is around engineering and developing. Getting close to the systems. Again, density is the feature. Okay, tightly coupled, interoperable systems, low latency. Get that data fast as possible in the place it needs to be. We hear that all the time. What are developers and architects thinking about? The ones who are going low-level coding, what are they thinking about? How do you guys help them? Is that something that you're doing a lot of work around? How do people build and integrate in rebellions?
Yes, basically that's why I'm talking about the open source ecosystem. Even low-level programming wise, we open on entire our low-level program, like something like the CUDA eventually. That's why all our developers optimize our chip, even not just the chipset, not just the PCR, as you mentioned. Our rack scale solution is our single product. So they always all partners. We can't do anything by ourselves. We need a partner for optics, also need some switch, all together optimized together at the rack scale solution. That's the vision of our Rebellion.
All right, well, I got you here since you're such an expert. I have to ask you, I'm curious, what's your view on scale up and scale out? How much work can be done to make them better? I see scale up, I mentioned some of the switches. I see opportunities to put more in a rack, scale across. I mean, scale out, obviously connecting racks. Some people have multi-rack systems, some want one rack. What's your view on scale up and scale out? Is there more work to do?
Basically, it's my personal opinion, not a personal. It's just the beginning of our research, entire domain here. Everybody talks about caving cache, but as far as I know, there's no de facto standard solution yet, even in the software side. First, we need some solution of the software side. It's going to be hardwired into hardware, and then we need a system level solution. Right now, the input and output sequence is pretty long from the Minimax 3.0. There's no de facto standard at all. First, we need to find a software solution. Then go to hardwire in the hardware, eventually cross-link optimization, optics, and all the material into the single part, then do actual system level optimization. From this perspective, we don't yet start anything. It's just the beginning of that journey.
Yeah, and there's a lot more to change. I mean, you're talking about custom silicon, getting things on the chip,
exactly
as tight as possible.
Exactly, but combined with the agent AI, there are a lot of CPU workload.
Yeah,
things changed a lot, going to be changed a lot. That's my.
So we're just at the beginning.
Just beginning of beginning,
yeah.
Combined with agent AI.
I love when you hear words like there's no standard yet on one of the most important things in these clusters is the networking.
Yes, yes.
Thank you so much. Congratulations on your success. A lot more going on. Obviously, the supply chain will get fixed. Rack scale era is upon us. Thanks for coming on theCUBE and NYSE Wired.
Thank you.
All right, I'm John Furrier. This is our AI Factory series, talking to the leaders, because like we heard, this is just the beginning. Things are going to get smaller to the system level. Software standards will emerge out in open source. All this will enable more and more change, faster agents, physical AI. The headroom is limitless in society, of course. We're doing our part here on theCUBE to bring that to you. I'm John Furrier, the host of theCUBE. Thanks for watching.